By the late 1930s, American railroading ran on a belief as old as the tracks themselves. Steam would always rule. Steam locomotives were not just machines. They were the culture, the pride, the muscle of an industry built on fire and boiling water. Crews trusted them. Executives understood them. Shops could fix them with torches, wrenches, and experience passed down through generations. Diesel power, by comparison, felt like an interloper. A strange, humming machine with no pistons exposed, no firebox to watch, no boiler to fear. It hid its strength behind metal panels and electrical cabinets. To steam men, diesel engines looked like factory equipment awkwardly mounted to a frame, unsuitable for real freight work. Early diesels did little to change that view. They were small yard switchers and light passenger units, producing only a fraction of the horsepower needed for mainline service. Their delicate injectors clogged, their compressors overheated, their electrical gear shorted out in rain and dust, and because they lacked the brute tractive effort of steam, railroads believed dieselization, if it ever came, was at least decades away. Most manufacturers agreed, all except General Motors. GM entered the rail industry without steam traditions or legacy products to defend. What they saw was painfully obvious. Steam was aging, expensive, and wildly inefficient. A modern, mass-produced internal combustion locomotive could, if engineered to survive railroading's brutality, replace entire fleets of steam engines. But engineering that machine was another matter entirely. By 1938, the most powerful diesel locomotives in existence produced around 900 horsepower. To dethrone steam, GM needed at least triple that output, and they intended to achieve it using a radical new engine, the 567, a high-speed, lightweight diesel unlike anything in global railroading. The locomotive built around that engine would be called the FT. Its A and B units together would produce 3,000 horsepower, a number that railroad executives considered almost irresponsible for a diesel. Even inside GM, doubts swirled. Engineers knew they were pushing the boundaries of metallurgy, cooling, and compression ignition. The FT's success depended on every component surviving stresses no diesel had ever endured. If the machine failed publicly, the entire concept of diesel freight locomotives might collapse for a generation. Yet if it succeeded, it could end the reign of steam. But in 1939, no one, neither railroads nor GM itself, truly believed the FT was ready. It was a bold idea, a dangerous experiment, and a mechanical leap of faith. What GM couldn't foresee was that this unproven locomotive, feared even by the men who created it, would soon march across the nation and challenge every steam engine in America. And within a few short years, the FT would do the unthinkable. It would prove steam was living on borrowed time. To understand why GM's engineers were uneasy about the FT, you must understand the limits of diesel technology in the 1930s. Diesel engines of the era strained even at modest power levels. Their pistons cracked under high compression, their injectors are clogged with impurities, their cooling systems boiled over during long climbs. No one had successfully built a diesel producing more than 1,000 dependable horsepower. GM planned to triple that number. The heart of the FT was the V-type 567 engine, a block designed specifically for locomotives, compact, modular, and, in theory, rugged. But forcing it to generate 1,500 horsepower per unit would push every component into unexplored territory. GM used aircraft-style engineering practices normally reserved for high-performance engines. Precision-ground crankshafts, advanced blowers, welded monocoque blocks, and carefully timed injection systems. It wasn't enough for the FT to work. It had to survive conditions no diesel had ever seen. Railroad skepticism made the task even harder. Steam crews dismissed diesels as weak and temperamental. Executives viewed them as maintenance headaches, fine for yard work, unthinkable for hauling heavy freight across the Rockies or through the blistering deserts of the Southwest. Railroads didn't want the FT, so GM would have to force them to witness what it could do. The plan was radical, a nationwide, no excuses, no fail demonstration tour. A 4-unit FT consist would run tens of thousands of miles across every major U.S. railroad, hauling revenue freight under real punishing conditions. No staged tests, no controlled environments. If the machine broke down, everyone would see. Inside GM, confidence and fear mixed uneasily. Engineers whispered worst-case scenarios, traction motors overheating on mountain grades, blowers failing at altitude, crankshafts snapping in the desert. A single catastrophic failure could humiliate GM and doom diesel mainline locomotives for years. Yet the FT pushed closer to completion. Its sheet metal fitted, its engines tuned to razor-thin tolerances. Factory workers sensed they were building something unprecedented. Sleek, enclosed, and intimidatingly quiet compared to steam. On paper, it was a 3,000 horsepower gamble. In reality, it was a declaration. GM wasn't introducing a new locomotive. They were challenging the entire ideology of steam. And the proving ground would not be a test track. It would be America itself. The FT demonstrator rolled out in late 1939 without ceremony. No crowds, no speeches. Railroads weren't interested in celebrating a diesel they didn't believe in, but the GM wasn't seeking applause. They were preparing for battle. The FT's mission was simple: run 35,000 miles across the continent, haul real freight, and survive what steam had mastered. The tour began on the Atchison, Topeka, and Santa Fe Railway. Santa Fe operated some of the harshest railroad territory in the nation, deserts where lubricants thinned to water, and grades where steam locomotives groaned under tonnage. Crews predicted the FT would melt its bearings before crossing the Mojave. It didn't. It pulled hard, ran cool, and burned astonishingly little fuel. Santa Fe supervisors kept checking gauges as if expecting them to lie. Then came the Rockies. Raton Pass had humiliated countless steam crews with wheel slip, overheating, and stalled trains. The FT faced it with no drama, just a steady hum as its traction motors delivered smooth, relentless torque. Diesel power didn't surge like steam. It didn't gasp or lose power. It simply climbed. Steam engineers riding in the cab stared at the meters in disbelief. "Are we really pulling this much?" one asked. From the Rockies, the FT pushed across the plains, down into the southern belt, then north toward Chicago. It ran day after day, sometimes week after week, with almost no downtime. Steam locomotives needed frequent servicing, fires cleaned, boilers inspected, rods oiled. The FT rolled on. Railroad shops inspected it at each stop. They expected to find cracked heads, burned bearings, worn brushes, anything to prove diesels weren't ready. Instead, they found almost nothing. A bolt tightened, a filter was cleaned, routine inspections, no major failures. Gradually, something changed. Steam crews, men who had mocked the FT, began to respect it. Not because it was beautiful or traditional, but because it kept showing up, hauling tonnage without complaint. The FT wasn't just surviving its trial by fire. It was rewriting the definition of railroad power. By the time the FT demonstrator reached the Midwest, the murmurs had begun. Dispatchers whispered about fuel logs that didn't add up. Road foremen compared tonnage charts and frowned. Crews who had mocked the FT now studied it with the same cautious respect they once reserved for a powerful new steam locomotive. But respect wasn't enough. Railroads didn't buy locomotives based on impressions or rumors. They bought based on numbers, cold, unforgiving, irrefutable numbers. And the FT was beginning to generate numbers that no steam engine in America could match. Steam locomotives devoured fuel. A 282 Mikado might burn 10 to 12 tons of coal in a long day's run. A big 484 Northern could consume twice that. Crews shoveled, stokers strained, tenders emptied, and still the firebox demanded more. Every mile required mountains of fuel and armies of laborers to mine, transport, and shovel it. The FT changed the math instantly. Run after run, the demonstrator consumed only a fraction of the energy steam required. GM engineers calculated the results carefully. Some railroads refused to believe them, so they rechecked the figures themselves, using their own scales, their own pumps, their own books. The answer was always the same. The FT could move a ton of freight up to 3 times farther per gallon than steam. That single statistic shook the industry. Steam locomotives demanded constant care. Every 100 miles, something needed oiling. Every few hundred, boiler washouts, inspections, ash removal, and flue cleaning. Every few years, if they made it that long, complete overhauls involving hundreds of man-hours. The FT seemed to ignore these rules entirely. Across thousands of miles, the diesel required little more than routine checks. No boiler scaling, no ash pan cleaning, no greased rods or blown piston rings. Engineers found themselves pacing around the locomotive looking for problems that simply weren't there. One superintendent summed it up bluntly. Steam needs a hospital, diesel needs a notebook. A freight locomotive's worth was measured in what it could pull. Large steam locomotives could muscle enormous loads across level ground, but they lost power as fires cooled, boilers tired, and crews fatigued. They fought the rails instead of cooperating with them. The FT, by contrast, delivered constant, even power from the moment its throttle advanced. Electric traction motors translated that power into smooth torque. No surging, no slipping, no struggling. Railroads assigned the FT loads they were certain would break it. The diesel hauled them anyway, often matching or exceeding the performance of two steam locomotives working in tandem. The data kept piling up. Lower fuel, lower maintenance, higher availability, equal or superior pulling power. Every railroad hosted the FT expecting to prove diesel hype was exaggerated. Instead, the diesel proved steam overestimated. As GM collected the results, railroad executives began to realize something unsettling. If the numbers held true across an entire fleet, steam wasn't just vulnerable, it was obsolete. The FT wasn't merely performing well, it was performing too well. And for the first time, railroad men, lifelong defenders of steam, felt a quiet, unfamiliar fear. What if this diesel really could replace everything? The FT demonstrator had faced harsh conditions before, but this test was designed to push it to its absolute limits. Steam locomotives dominated American railroads for decades, and the old guard engineers and executives were determined to see the diesel fail. They didn't just want to test it, they wanted to prove it couldn't handle the demands of real freight service. The FT was assigned to a route known for its difficult terrain, a section of track that had earned the nickname the Anvil. It was a relentless climb, and past steam locomotives often struggled, overheating or slipping on the rails. GM engineers expected this challenge to show the FT's weaknesses, but they also knew the machine had been built with extraordinary care. On the first day, the FT pulled a train of nearly 100 freight cars, more than 5,000 tons. Steam crews watched in disbelief as the locomotive climbed steadily, its diesel engine humming, its electric traction motors delivering smooth, constant power. There were no hiccups, no wheel slip, no dramatic struggles. Mile after mile, the FT moved forward without faltering. By the time it reached the top of the grade, the railroad men who had doubted it were silent. Some stared at the gauges, checking the numbers repeatedly, as if expecting a mistake. Others simply shook their heads, unable to believe what they had just witnessed. A veteran engineer muttered to his crew, "If she makes it through that, steam's already finished." The railroad wasn't finished testing it, though. They pushed the FT to run continuously for days. No maintenance stops, no inspections beyond the most basic checks. Steam locomotives required frequent care, water, coal, ash removal, boiler inspections, but the FT kept going. The diesel ran reliably, only needing refueling and minimal adjustments. Every time the railroads tried to catch it failing, it continued to run. Next came speed tests. Steam engines had always been faster on certain freight routes, so they timed the FT against schedules it was never intended to meet. The diesel kept pace and even beat expectations, showing it could handle fast, heavy freight consistently. Finally, endurance became the ultimate test. The railroad ordered the FT to keep running with minimal support, covering long distances without scheduled stops. Even under these conditions, the machine didn't break. Its engine, motors, and systems held up. It rolled into each new station ready for more work, leaving the crews in awe. After weeks of grueling demonstrations, the steam men had no choice but to admit what they had witnessed. The FT wasn't just reliable, it was superior in many ways. Fuel efficiency, maintenance, hauling power, and endurance all exceeded what steam locomotives could offer. The doubts that had surrounded diesel technology for decades began to vanish in the face of this single locomotive's performance. By the end of the trial, the mood among the veteran steam crews had changed completely. They no longer mocked diesel engines or dismissed them as toys. They understood that something fundamental had shifted. The FT had proven it could replace steam locomotives, and it did so in a way that no one had expected. For the first time, the future of American railroads looked unmistakably different. By the early 1940s, the FT had done more than just survive its trials. It had changed minds across the country. Railroads that had once scoffed at diesel technology were now forced to admit what was impossible to ignore. The FT worked. Not occasionally, not under ideal conditions. It worked consistently over thousands of miles, carrying heavy freight through mountains, deserts, and plains without the constant maintenance that steam required. Executives began calculating the economics. Steam engines needed coal, water, frequent repairs, and large crews. Each locomotive had hidden costs that added up over months and years. The FT, by contrast, burned diesel efficiently, ran longer without attention, and required fewer personnel. Maintenance was predictable and manageable. Every railroad's accounting books told the same story. Diesel could save money, and a lot of it. The shift wasn't just financial, it was cultural. Steam crews had grown up knowing the rhythm of fireboxes, the hiss of boilers, the smell of coal smoke. Diesels were quiet, clean, and almost alien. Some engineers admitted they missed the drama of steam, the power of a firebox, the roar of a wheel set spinning, but even they could not deny the FT's practical advantages. It moved more tonnage with less effort, more predictably, and more reliably than any steam locomotive. By 1941, several major freight lines began placing orders for production FT units. The demonstrations had convinced them that diesel wasn't a fad. It was the future. In yards across the country, crews began learning to operate the new machines. Workshops adapted to service electrical systems instead of boilers. Fuel depots switched from coal to diesel. A quiet revolution was taking place on the rails. The FT's influence extended far beyond the individual locomotives. By proving that a diesel could outperform multiple steam engines, it forced railroads to rethink scheduling, train length, and freight logistics. Where once a mountain grade might require 2 or 3 steam locomotives to push a heavy freight train, a single FT could manage the same load. Lines that had once struggled to meet deadlines found new efficiency. Timetables became tighter, deliveries faster, and profits higher. Even in cities, the changes were noticeable. Diesel locomotives produced less smoke and soot, reducing pollution near stations and yards. Railroads could operate longer hours without creating unbearable conditions for nearby residents. The quieter engines also allowed engineers to better hear signals and track conditions, a subtle but important safety improvement. Despite its success, the FT remained a symbol of risk and innovation. GM had gambled on a technology that most considered unproven. The engineers had faced skepticism, financial scrutiny, and technical challenges that could have ended the project. Instead, the FT proved that careful design, rigorous testing, and a willingness to challenge conventional thinking could redefine an entire industry. By the mid-1940s, the first wave of diesel locomotives was fully integrated into American freight service. Steam, once unquestioned, began a slow but inevitable decline. The FT had not just survived, it had demonstrated a new path forward, one that would change the face of railroading forever. By the time the last FT demonstrator had completed its final trial runs, the future of American railroads was clear. Steam locomotives, once the undisputed kings of freight, were now on borrowed time. The FT had done more than prove itself. It had rewritten the rules of what a locomotive could be. Railroad executives, initially skeptical, were now converts. Orders for diesel units poured in from coast to coast. GM's gamble had paid off. A machine that had once terrified its own creators for its boldness and unproven technology had become the standard-bearer for a new era. Railroads realized that diesel engines could haul longer trains over more difficult terrain with fewer stops, less maintenance, and lower operating costs. Every mile of track became more productive, every schedule more reliable. The crews who had once feared diesels grew to respect them. Engineers learned to appreciate the constant, steady power, the reliability, and the efficiency. Firemen who had spent years shoveling coal found their work transformed, no longer tied to endless stoking, but focused on monitoring gauges and ensuring smooth operation. The human toll of steam, the long hours, the backbreaking labor, the constant risk of boiler failures began to fade. By the late 1940s, diesels were no longer the exception, they were the rule. The FT had shown that replacing multiple steam locomotives with a single diesel unit was not just possible, but advantageous. Entire fleets were converted and the dieselization of America's railroads accelerated. Steam engines, once symbols of power and prestige, were gradually retired, their boilers scrapped, their whistles silenced, and their days of dominance ended. Yet the FT's influence went beyond economics and efficiency. It represented a shift in how American industry approached innovation. GM's engineers had taken a calculated risk, designing a machine that no one else dared to try. They had relied on careful testing, detailed calculations, and relentless experimentation to prove that a new technology could outperform a trusted standard. That lesson resonated far beyond railroads, influencing automotive, aviation, and manufacturing engineering in the decades to come. The FT also left a human legacy. The engineers, mechanics, and crews who worked with the first diesels became the pioneers of a new kind of railroading. They documented lessons, refined maintenance techniques, and trained the next generation. In doing so, they ensured that the success of the FT was not an isolated event, but the foundation for a permanent transformation in transportation. Decades later, historians and engineers still cite the FT as the machine that changed American freight. It was a locomotive that succeeded in ways even its creators had never imagined, proving that bold ideas, rigorous engineering, and careful testing could overturn entire industries. Steam had once been unbeatable. The FT had not just challenged it, it had replaced it. In the end, the 3,000 horsepower FT did more than move freight. It moved the future, and it did so quietly, steadily, and with a certainty that left no room for doubt. The diesel revolution had begun, and the FT would forever be remembered as the locomotive that made it inevitable. The FT's influence didn't stop at the railroads. While freight efficiency, lower costs, and reduced maintenance had already reshaped American logistics, the locomotive also changed the culture of engineering itself. GM had taken an enormous risk by producing a 3,000 horsepower diesel in a world dominated by steam. At the time, many considered it reckless. Diesels were untested, temperamental, and unproven for the heavy demands of cross-country freight. Yet the FT succeeded where others feared failure, and that success sent ripples far beyond the tracks. Railroad engineers began to rethink long-held assumptions. Steam had been the standard for more than a century. Crews were trained to read boilers, anticipate failures, and manage every nuance of fire, water, and mechanical wear. The FT introduced a different kind of discipline: electrical traction, diesel power, and mechanical precision. It demanded a new type of skill set, and with it came a shift in the culture of the workforce. Firemen no longer shoveled coal for hours on end. Engineers learned to monitor gauges, maintain steady power output, and rely on predictable performance. The risk of catastrophic failure decreased while operational efficiency skyrocketed. Economically, the impact was immediate. Railroads could now move heavier loads over longer distances with fewer locomotives. One FT could replace 2 or even 3 steam engines. Fuel consumption dropped sharply, maintenance became routine instead of reactive, and crews could focus on logistics rather than firefighting boilers. Every railroad that adopted dieselization saw tangible results: reduced costs, faster delivery times, and higher reliability. The FT wasn't just a locomotive, it was a blueprint for operational transformation. Beyond the workforce and the numbers, the FT reshaped how America imagined technological progress. Engineers across industries studied its design. The idea that a single bold innovation could outperform decades of established technology was revolutionary. It showed that careful design, methodical testing, and precise engineering could overcome entrenched skepticism. This mindset spread beyond railroads. Automotive companies, aircraft manufacturers, and heavy industry all took note. The FT became a symbol of what American engineering could achieve when creativity met discipline. The locomotive's influence also left a lasting legacy on urban life. Steam engines had dominated the landscape for over a century, filling cities with smoke, soot, and noise. Diesel engines were cleaner, quieter, and less intrusive. Communities near rail yards noticed the difference immediately. Tracks that had once been a source of pollution and disruption became more manageable, and railroads could operate longer hours without generating complaints. The FT didn't just change industry, it quietly improved the environment of the cities it served. By the late 1940s, diesel locomotives were no longer experimental. They were the backbone of American freight. Steam engines gradually disappeared, their whistles silenced, their boilers scrapped. The FT had not just survived, it had proven that an entirely new approach to locomotive design was possible and superior. It created a foundation for the future, showing that careful engineering, bold ideas, and relentless testing could overcome the most entrenched traditions. Even decades later, the FT's influence is clear. It shaped the way engineers think about innovation, risk, and reliability. It inspired generations to question assumptions, embrace new technologies, and push the limits of what seemed possible. The diesel revolution that swept across American railroads began with a single 3,000 horsepower machine, a locomotive that challenged the status quo and succeeded spectacularly. In the end, the FT did more than move freight. It changed the future of railroads, American industry, and engineering itself. Its legacy endures, not just in the tracks it ran, but in the mindset it created, a mindset that still shapes innovation today.